Hello everyone, I am Talha bin Shaukat and today I will present my project Hardening Crate Loading and Unloading Cell that I developed with my teammate Ahmed Ali Khan Sharwani. Our goal was to design and simulate a robotic cell for crate assembly, loading and unloading. So we used specialized gripper for efficient handling of hardening objects like piston and validated our solution in a real-world environment. Key accomplishments include simulating the crate assembly process, creating a 3D piston model, testing and implementing our prototype, and we developed a gripper for assembling and object handling. This is the robot that we used, and it is Kamau robot that had payload of 45 kg and weight of 680 kg. This is the end effector that we used, and it is MRP-46 Pneumatic Magnet gripper that has the lifting capacity of 46 kg. It offers strong magnetic force in low temperatures, no moving parts, reducing maintenance, and fail-safe design for added safety. These are the models of our end effectors and flange. These are the 3D models that we used in our simulation that will be shown later on in the video. This is the process map of our whole project. And according to this slide, the process flow of our robotic system and each stage from picking up crates and assembling them to handling pistons efficiently. By mapping out the process, we ensure smooth and error-free operations. These are the equipment that we use for hardware implementation. And this is our final assembled crate and piston. So using Visual Component software, we simulated the entire robotic workflow. This helped us optimize the movements of the robot, minimize errors, and enhance efficiency before real-world implementation. In this video, we are going to present our final demonstration in a real-world environment. And this video will explain whole end-to-end process. Thank you.